Let's finish up the 4.3. Remember 4.3, I told you there's a few things I didn't show you. So when you do your homework problem, you may not know how to do it. Even though it's easy, you may not know how to do it. All right, everybody put away your phone. Is everybody ready? Put your phone in the silent or turn it off. Let's go and do it. Properties of a definite intervals. It's still a continuation from 4.3. A definition of two special definite intervals, two special cases. If f is defined at x equal to a, look at my upper limit and my lower limit. My lower limit, look at upper limit. What happened? X is a and then x is what? A. So do I have a width? There's a, my x is a, and then the other one is also what? A. So do I have any width? The width is what? 0. Am I right?
Right.
So my width, remember we always drawing a rectangle to figure out our area under the curve. Are you with me, class? But if you don't have any width, if the width is 0,
Can you have a point on the line?
no, we're saying not even a line. It's the same number. It's A to A, so you don't have any differences.
Okay.
What's A minus A is equal to what? 0, isn't it? So you don't have any width. That means 0 times any height is what? 0. So that's why if you have upper limit and lower limit, upper limit is the same, your area is what? 0, because you can think of height times what? 0 is what? Of course it's 0, right? Does it make sense why this is equal to 0? Okay. Next one, if f is integrable on a to b, lower limit to upper limit, then look at this. I am changing my limit, right? I put the upper limit in the bottom and lower limit in the top. Notice that? So which means you're doing the opposite way. So you become a negative in the front.
Okay.
Are you with me, class? So the function is the same, the width is the same. If I change my limit, upper limit to lower limit in opposite direction, then you get a negative of that.
Okay.
Is everybody with me? Okay. It's just a negative of that. So this one we know right away. What's this area equal to? Look at that. My lower limit and my upper limit is what?
0.
Same. So in other words, my width is what?
0.
0. So 0 times anything is what?
0.
0. So my height is 0. What you can say? 0 times f of x, whatever. Okay? Still is 0, right? What about this one? We learned this. If I have this, when the limit is opposite direction, I need to rewrite it, right? Put the lower in the bottom and upper layer on the top. So I rewrite it as what? 0 to 3, and I still do x plus 2 dx, but I will put what? Negative in the front. Are you with me, class? By definition, if I put the upper limit in the bottom and lower limit in the top, I need to change it, all right? And then put the negative in the front. All right. Let's take antiderivative of this. What's that equal to? Negative in the front, I have this. What's that equal to? X squared divided by 2 plus 2x. I'm gonna what? Evaluate that from x equal to 0 and then what? X equal to 3. Are you following me, class? Remember, I am adding and divide because it's antiderivative. Derivative is what? Subtract 1 and multiply. So I will do opposite, which means what? I add 1 and then divide that number. Remember this is 1 power, right? 1 plus 1 gives you 2, so divided by 2. Is everybody with me? You got to practice, class, okay? You got to practice. It's easy, but still have to practice. So what's my answer then? Don't forget I have negative in the front. So plug it in. 3 squared over 2 plus 2 times what? 3. That's first one. And then what? Minus. A class, did you see this minus sign also?
Yes, I see.
But since this is a 0, is everybody with me? This is from upper limit, I'm replacing x with a 3, and over here is my lower limit, x with what? 0. Is everybody with me?
So you really adding it or just wrong?
It's a, you're subtracting, but you also have a what? Negative sign in the front. So actually this become a what? Positive, right, exactly. All right. So now, but this one over here just become a what? Simply become a 0. Because 0 over 2 is a 0. 0 times this is what? 0. So I don't have to subtract anything, in other words, okay? So this, what you have is what? Negative 9 over 2, negative 6, which is the same as, this is a problem that we did yesterday, is that what it is?
So you have to negative 21 over 2.
Yeah. Okay, is everybody with me now? This is a problem that we did yesterday. But now, remember, since I have flipped my limits, the boundaries, that's why you get a negative answer. Okay?
So right there, right there, is that plus 0?
Yeah, because negative and negative makes what?
Okay.
Positive. Yeah. Right here you go. Don't forget to sign your
Oh,
name.
yeah.
All right. Moving on to the next one. Is everybody good? All right. All right, next one. Here, additive interval properties. If I give you A to B, all right, say 1 to 5, I can make it into 1 to 3 and 3 to 5. Is everybody with me? I can break into 2 parts. That's still fine. You can add intervals, you can subtract intervals, you can multiply intervals, just like numbers. So over here, this is a perfect example. When you graph this, it's my graph looks like. Are you with me? That's absolute value graph just like that. So, looking at this, my graph is what? This is my slope is what? Negative. So this is actually, this graph right here is negative x. What's this graph here? Positive x. Absolute value, you always have 2 sides, remember? Just think about this one. If I give you absolute value equal to 3, what that means? This could be what? It could be 3, it could be what? Negative 3. Same thing. Whenever it confuses you, just think about simply a number. So absolute value of x really means I have what? Positive x, I have what? Negative x. For negative x, what am I looking at? What's my limit? Negative 1 to where? 0. But this from here to here is that graph. That function I'm gonna use. What's this function? Starts at where? 0. Where does it end? 1. So that's why you have 2 parts. So even though I gave you limit evaluating from negative 1 to 1, class, be sure you understand this, because I usually give all exams like this kind of problem, because this one will make you understand. But this will test you, your understanding, and also test you, your integration, whether you know how to integrate. So I like problems like this because you have to think about it. You have to know how to break them as a 2 parts. If I give you absolute value, you have to always make it into 2 parts. One for the what? Negative slope, one for the what? Positive slope. Are you following me, class? Okay, I just give you a very big hint. Am I right?
One for the
Okay,
negative.
if I put there no star by this problem, right? Because it's not going to be exactly absolute value of x, but I will give you something to do with the what? Absolute value problem.
Okay.
Because you will mainly test your understanding of absolute value and always test you what? Integration. Do you know how to integrate? All right, so does everybody understand why do I have two parts here? Does everybody understand? If you don't, you gotta ask me now. Does everybody understand this came from which one? That one right here. And this one, this is what? Negative x. This is what? Positive. Are you with me, class? It's a positive slope. Negative slope. Is everybody with me? All right. But you know how to integrate that. We're going to do one part at a time. So this means, okay, negative x squared divided by 2. I am going to evaluate it, x equal to negative 1 and x equal to what? 0. What's the other one? Exactly same thing. But this time I'm going to evaluate where? X equal to 0 to x equal to what? 1.
Oh. I got it.
Are you following me, class?
I got it.
Colin, are you with me?
Mm-hmm.
Okay. So, now, so what do I have here? So I got negative sign in the front, I will put what? 0.
Huh? She has a question.
Yes.
I missed it, like, you put from 0 to negative 1 to then 1. Oh, because of the graph?
Yeah, your graph, this graph is what? Negative 1 to where? 0. This graph starts at where? 0, and where does n supposed to be? 1. Because they gave me negative 1 to 1. They already gave me this two number. But I need to figure out what's my breaking point, what's my middle point that I'm gonna stop. Middle point is what? 0. Because 0 is where you change your slope. From negative 1 to 0 is what? Negative 1. From 0 to 1 is what? Positive 1 slope. Are you with me, class? So we figured out which number. That's the number that we figured out. Negative 1 and 1 is given. We're gonna use whatever number they gave me, lower limit and upper limit. But what did I also find? I found the what? Middle number where it's supposed to be breaks, okay? Where does change its slope. It was 0 happened to be here. If I use different number, then it'll be a different number. I will show you in a minute, because I want to make sure that you understand.
Okay.
All right, so let's finish this one up. So that's my, I just plug in that one, right? Now, minus my lower limit, which is what?
What?
Okay, this is what I just did. Am I right, class? All right, now I gotta do which one? That part.
Part.
I'll use different color. Is everybody with me? This part is right here, I just did.
What's that?
And this part is what? Over here. I just did. Are you with me, class? I got two intervals. So that's why I have an upper limit minus lower limit, and then I have a what? Upper limit minus what? Lower limit from this integrations. Okay. So now just simply calculate that. What's that equal to? This just simply equal to what? 0. That's just simply equal to 0. What's this equal to?
1
Negative, and then you got negative signs, so negative makes what? Just a positive 1/2. Is everybody with me? Because this is 1/2, but you got one negative sign here, that makes what? Positive 1/2. All right. And over here, well, this become a 0. This is what? 1/2. So it gives me what? 1.
One.
Okay. Hey, what did you just find out, class? This gives you exactly same area as what? That one. So can I just calculate one of them and multiply by 2?
Word, yes.
Then I will save some work, right? Instead I'm doing a 2 evaluation of integrals. So whenever you have, are you with me, class? I'm trying to give you
A shortcut.
shortcut. So whenever you have absolute value, we realize the area over here is exactly the same as what? Area over there. Why do I need to do two calculations when I know they're exactly the same? Why don't I just multiply by what? 2. So in other words, can I do this? Can I just simply do this? I said 2 times -1 to 0 and negative x of dx, right? I can do that, right? They give me the same answer. Or I can do what? 2 times 0 to 1 and x what? dx. Either way, I get the same answer. Just remember this. This area is same as what? That area. So I don't need to multiply, I don't need to evaluate twice. I can just evaluate this part, and then what do you do? Multiply by what? 2. Because you have 2 of them, 2 exactly the same thing. Are you following me? Okay. This is a very important concept. You need to know that geometrically, you can see that they're exactly the same area. So I can save myself a work by just evaluating one of the integrals, and then what do you do? Multiply by 2. They're exactly the same thing, have 2 of exactly the same thing. Is everybody with me? Okay. All right. So now, if you don't, I can erase, and I'm going to show you different absolute value, just to make sure that you understand. Everybody understand why this is a 0 right here, right? Okay, now let's figure it out. If it's not a 0.
Sorry. So we only worry about the middle.
Right, we need to figure out where the slope changes. All right, if I give you problems like this, class. All right, this is my graph. All right, which means my absolute value is Are you with me, class? This is my graph. I have this absolute value, x minus 2 of absolute value. Is everybody with me? This is my graph. So I am looking for area of what? All right, my graph is not so evenly distributed, but they're supposed to be exactly the same area, okay? My graph is a little bit uneven because my 3 and 4 increment is bigger than 1 and 2 here. But they're supposed to be the same, okay?
Okay.
All right, so class, look at this. How did I know to stop at right here? Because what? I'm gonna solve this one, set them equal to 0. So I'll do x minus 2 equal to 0, then x equal to which number? 2. So 2 is where you change your slope. Okay, so I can make this into problem then what? 0 to 2, and then what? That's what I'm gonna have. So this is x minus 2, and this is what? X plus 2. Are you with me, class? So, but I decide not to do it twice. And I don't like to multiply doing a negative problem, so I can just make it into what? 2 of what? This one.
Right.
So everybody with me? I'm not gonna go through all the way. I want you to just understand the concept. Is everybody with me right now? Are you following the concept? It's very important that you need to understand the concept. How I broke my 2 parts. You need to figure out how did I get this 2. This 2 came from where? This absolute value, solving this absolute value. You set them equal to 0, figure out what x equal to. What x give you 0? Is everybody with me? Okay.
I'm trying to figure out why did you say as a negative right there?
Where the negative?
In the second. right
Remember,
here.
this is a negative slope.
Okay. Oh, so you negative and then the positive side.
Right.
Gotcha.
And this is what? Positive. There's 2 equations. This line right here is x negative x minus 2. This is what? X plus 2. That's my slope is.
So would that be x plus 2 right there?
Yeah. If I do this is the same as what? Negative x plus 2. Yes.
writing this bottom one down.
Okay. So you have a choice, class, are you with me? I can evaluate two of this, I can evaluate two of this, or what? Each one of them, whatever you wanna do. Because they're supposed to be evenly, what? They're exactly same. So I can just calculate one of them and multiply by 2.
Okay.
Mm-hmm.
Where did they two come from in the bottom one?
She multiplied by 2.
Just 2?
Oh,
What?
okay. I
Yeah.
didn't say multiple.
Yeah, because I have how many? 1. Ooh.
Ooh.
I was always right. Ooh, this huge thing. I got 1 area and then what? 2 area, 2 of them. Is everybody good? All right. Okay, so as I said before, you can add and subtract your intervals, you can multiply by constant, you can do all that. Over here, okay, this is another one. This is also understanding problem. All right, they gave you this problem. Okay, they said don't solve this one, but just use what I gave you. Pretend you don't know how to solve this one. Of course you know how to evaluate, okay? But pretend you don't know how to do it. They said they gave you this to use. Only use this information. All right, are you with me, class? They gave you that information. So they told you 1 to 3, limit 1 to 3, x squared, what's that equal to? 26 over 3. So I'm gonna break this into what? This is a problem I need to figure out. So I will make this into 3 integral problems. Are you with me? There's 3 terms. All right, I'm making 3 problems here. Is everybody with me? I break this 1 problem into what? 3 integral problems. Is everybody with me? First one, I put down right here. Second one, 4x, I put the 4 in the front of the number, in front of the integral, and then put x in the inside the integral. Next one, I just put negative and 3 and that. Is everybody with me? This is exactly the same as that one.
Yeah.
All right, now, they told you, okay, let's now evaluate this one. Let's use what they gave. They gave you x squared equal to what? 26 over 3. So I have a negative. So my answer should be then what? Can you guess? The positive x squared give you 26 over 3. What's a negative would be then? Negative what? 26 over what? 3. Does everybody agree?
Yes.
It's from where? From 1, I can conclude that. All right? From 2, what can you say? 2 says what? This gives you a 4. But I have which number in the front?
4.
Right. Right, so it'll be then 4. That's from which one? From 2, that I know that's supposed to be 4, right? So this part right here, class, are you with me? That's equal to 4. This is equal to what? Negative 26 over 3. Is everybody with me? What is this equal to? It says what? If it's 1, you get what? 2.
9.
But I have what? 3, am I right? What is this? 2. So I'm gonna say, how about I put this 3 in the front so you can see it? I'll put like that. All right, you heard with me? And you're gonna say this is what? 2,
Yep.
right? Are you following me, class? So yes, I can evaluate this if I want to. But pretend, if this problem is very complicated, I don't want to evaluate. I want to just use information they gave me, okay? Which I can do that. Then I got my answers done, then I'm done. I'm just simply add all these things and I got my answer. This is from where? From 3. Is everybody with me? That came from one equation. This came from what? From 2 equations. This came from where? This 2 came from 3rd equation. Okay, 3rd integration. So I just simply multiply them and add them and I'm done. So this is just 16. And this is what? 6. So I have negative 26 divided by 3 and then plus what? 10.
Yeah.
10. All right, so I will have negative 26 divided by 3 plus what? 30 over 3. 10 is the same as 30 over 3, right? So your answer is what? 4/3. I just simply make this to be a fraction, okay? 10 is the same as 30 over 10. 30 over 3, because 30 divided by 3 is what? 10. I make it into same denominator so I can add and subtract fraction. All right, that's the reason. Does everybody see that? Whenever you have a fraction problem, you gotta have the same denominator, otherwise you cannot add and subtract. All right, we good? All right, we're done. So. Are you still writing that down?
Yes.
Okay. And also, class, you know you have your PowerPoints in your Blackboard, right? I put all your PowerPoints.
Why did it go to minus 30 over 3?
This is 10 over what? 1.
Okay.
I don't have the same denominator.
Okay,
So I make this into 3 to have the same denominator.
okay.
I mean, if you want, you can just put this into a calculator. Negative 26 over 3 plus 10, it will give you 4/3.
Okay.
I just did it in a long way. Is everybody good? All right, I want to show you picture-wise what this means.
Okay.
By the way, I hope you enjoy calculus class. It's like something that you can use. It's not just like doing algebra and you have no idea where you're using. But calculus you can literally use. Like you doing a geometry like real figures, figuring out instead of trying to figure out what shape that is, but I can just do intervals, right? How many people remember all the shapes? I don't remember all the shapes, how to evaluate all those areas, but I know how to do calculus.
You make sense?
Huh?
You make sense?
Yeah, yeah, I do. All right, this is what it looks like also. In class, this is very important. If you have a function, this is your f function, and this is your what? G function. So in other words, they're telling you f function is smaller than what? G function. So when you take an integral, it's the same way. The integral of f function has to be what? Smaller than what? G. Taking an integral because g function is what? Higher than f function. Just think about the y values. Where's this y value? I say this is 3. Then it should be what? This will be what? 6? Are you with me? So this is definitely has what? Larger y value than what? F function. So if you take an integral of that, yes, the area of this one is what? More than area of which one? This one, how much more? This much more. Is everybody with me? Okay.